You are now standing at listening point 4 on the top platform. In front of you, the coking plant and the vast industrial landscape of the central Saar Valley spread out. Völklingen was and continues to be one of the most important centres of heavy industry in the Saar region. How has industry altered the landscape? What remained after the demise of the steel industry?
The history of Saarland is closely interwoven with the iron and steel industry and coal mining. 1593 saw the first mention of an ironworks in the area of Neunkirchen in the eastern part of the state. Völklingen was the youngest of Saarland's iron and steel works.
The Völklingen ironworks characterised the people and the landscape of the central Saar Valley. Industrial landscapes are formed by various manifestations of industrialisation: the roads, the altered course of rivers and the railway lines, whatever else industry leaves behind, for example, the giant tips from mining and from the iron industry, and by the industrial plants themselves, which occupy large areas of land.
The view from the top platform shows all these consequences of industrialisation. In the background, the great slag heaps from the Völklingen ironworks, dubbed Hermann and Dorothea, as we have said, rise up. Artificial hills which grew steadily with the development of the works and which still dominate the landscape today.
Later on, it became possible to put slag to profitable use. Slag sand and slag bricks became important building materials for roads and houses. Today, in many parts of Saarland, you can still find buildings made with that grey slag brick.
On the right-hand side of the Saar, you can see in the distance the rolling mill of Saarstahl, the so-called Nauweiler Gewann, built in 1954 under French sequestrators' receivership. This industrial plant stretches for over 3/4 of a mile along the river. Saarstahl has come to specialise in the production of rolled wire, steel bars, semi-finished goods, sectional steel and open-die forgings. Saarstahl products are important preliminary products for the automobile and supply industry, the building industry, power machinery and general machine construction, and the aviation and aerospace industries. With a workforce of about 5,000, the company is one of Saarland's largest employers. Things were pretty tight on the top platform, which is over 200 metres long and 27 metres above ground level. Incessantly, the monorail cars travelled full to the blast furnaces or back down again empty to the burden shed or the coking plant. When the charging system was built, the blast furnaces were still of different heights. Special lifts had to be constructed to compensate for those differences. It was not until 1926 that this major problem was solved. All the blast furnaces were made exactly 27 metres high, and from then on, the top platform was all on one level.
The process of filling the furnace was known among the blast furnacemen as charging. Charging comes from the Latin carus, a wagon, and thus has the same origin as both car and cargo.
The blast furnaces were filled in layers. A layer of ore, sinter or additives always alternated with a layer of coke. One charge, i.e. a layer of ore or sinter and a layer of coke, consisted of 15 to 17 monorail cars filled to the brim. One car held 2 cubic metres of material, in other words about 1 tonne of coke, or, on account of its higher density, 2.5 tonnes of ore or sinter.
Apart from iron ore, sinter, additives and coke, the blast furnace was also charged with ferruginous waste products from industry or waste incineration. For that reason, the blast furnacemen also referred to it as the glutton.
8 monorail cars were positioned around the hopper, and the hood, the upper cover of the blast furnace, was raised. Beneath the hood there was a second cover, the bell. It remained closed and thus protected the workers from escaping blast furnace gas and prevented the furnace from cooling down. The material was tipped onto the bell, and then the hood was lowered. When the hood was closed, the bell was lowered, and the material fell into the shaft of the furnace.
If you go down the steps along the blast furnace, you will come to the tapping level. That is where the pig iron was tapped from the blast furnace. But how was the blast furnace constructed? How often was it tapped? How much pig iron did it produce? And wasn't it dangerous with all that red-hot pig iron flowing out? The foot of the blast furnace was the workplace of the foundrymen. This was where the long process of iron production came to an end. And this was where the molten pig iron was tapped.
Down here was where the foundrymen worked. This is where the long process of iron production came to an end and where the molten pig iron was tapped from the blast furnace.
The blast furnaces at the Völklingen Ironworks came into being between 1888 and 1916. Having said that, they were renewed, altered and extended on several occasions. The 6 furnaces in the form you see them now date from the 1970s.
The blast furnaces in Völklingen are surrounded by a sheet steel shell 3 centimetres thick. Inside they are lined with fireproof bricks, but not even that was sufficient to tame the fierce heat on the inside of the furnace. All the time, water trickled down the outside walls in order to keep the shell cool.
In the upper part of the blast furnace, the temperature was about 200 degrees Celsius, the kind of temperature you might normally set in your oven at home. However, it was much, much hotter on the floor of the blast furnace where you're standing now. There, temperatures of up to 2,000 degrees were reached. This zone of the furnace was where the hot blast from the blast heating apparatus was blown in to fan the blaze.
Every 2 to 2.5 hours, a blast furnaceman tapped the furnace. In the steel shell, there were 2 tapping holes for pig iron and slag. The holes were filled with a clay shale plug, which the blast furnaceman could drill out and then close up again afterwards. In earlier times, the workers used to move in with a hammer and chisel to make a hole in the blast furnace for the pig iron to flow out of.
This was extremely dangerous work. As soon as the pig iron came into contact with oxygen, it began to spray wildly. White hot droplets of molten iron hurtled through the air. These splashes of iron, known by the blast furnacemen as foundry fleas, could cause severe burns. Later, the tapping process was mechanized. Machines opened the blast furnace and closed it up again afterwards.
At each tapping, some 130 tons of iron flowed out. That meant a pig iron yield of 1,100 tons per furnace per day. The molten pig iron was taken to the steelworks by rail and further processed into steel.
From the blast furnace tapping, follow the visitor's walkway across the bridge into the coking plant. There you will find listing point 5.